Welcome back. This question is about geometry and trigonometry. All right, the first part is asking you to prove the trig identity 1 plus 2 cos x plus cos 2x, that left-hand side reduces to 4 cosine squared of half x, everything multiplied by cosine of x. So we want to prove that the left-hand side there is the same as the right-hand side. Ideally, you can work with the right-hand side and show that it's the same as the left-hand side, or work with the left-hand side and show that it reduces to the same thing as the right-hand side. In this case, of course, it is easier to work with the left-hand side and show that it turns out to be the same as the right-hand side. Part B of the question is a reduction formula. So we are told to express 5 sine x minus 12 cosine x in the form r sine of x minus alpha, where alpha is actually just what we call a phase difference in electrical engineering and other areas like in physics. All right, so alpha there is a phase angle, but you don't need to worry about it. It's simply mathematics here. Okay, so we want to do that. It becomes useful to be able to express an expression that contains sine and cosine into, to reduce it to an expression that is purely in terms of either sine or cosine. This becomes useful if you're going to be asked to sketch the function and you do not have a calculator with you. Okay, if it's an exam question where you cannot use a calculator and you are still asked to sketch the function, then it is impossible to sketch it when it is in terms of sine and cosine. But once you reduce it into either sine or cosine, it suddenly becomes much easier to simplify or to sketch, okay, or even to solve the equation. All right, which is what part 2 of B is asking us. So once we've converted it into r sine of x minus alpha, we are going to be able to solve that equation in part 2. Let's see how we go through this problem. So the first part is for us to prove this identity. We want to show that this left-hand side is the same as the right-hand side. I would have preferred to write this here, but it means I have to do a lot of erasing, so I think it's just fine that I type it, and also because it is neater for students who do not like when work is not presented neatly. So let's just do this the same way we've been working them out. So we will work with the left-hand side, and we will show that this reduces to that. Okay, in order to do this, we will need to first of all use the double angle for cosine, because I'm seeing cosine of 2x here. So this is a double angle. Twice x is double angle. So because this is a double angle, I want to make use of that. Now I know the double angle formula for cosine. We know that cosine, in fact we call this a compound, it comes from compound angle formulae, but let's just work with the double angle now. So cosine of 2x, we should know, is the same as twice cos squared x minus 1. So this term here can be expressed like this, okay, from the double angle formula, right? Okay, also we know I'm also going to use the double angle formula to express cosine by itself, right? So cosine of x can be expressed as cosine of twice half x, like this. So cosine of x can be expressed as cosine of 2 into x over 2, right? So half of x times 2 is actually just x, right? But I'm doing this so that I can make use of this idea, right? So because now I have twice half angle, right, I can now express this the way I expressed this. So it's going to be 2 cosine squared of x over 2 minus 1. So notice that this is the same as this, except where there is x here, we remove and put half x, like that. Okay, so all this is going to be useful, as you will see. All right, so now I'm going to express back my left-hand side. All right, our left-hand side is 1 plus 2 cosine of x plus cosine of 2x. So I'm going to remove that and replace it with its identical term All right, so remove that and put that because they are the same. But cosine squared of x is the same as cosine x times cosine x. So I'm going to write this as twice cos x times cos x minus 1. So if I do that, all right, this is just cosine x cos squared of x. All right, so I've expressed it this way because I want to get rid of just one of them. All right, so I will get rid of this and replace this with this because that is cosine of x. So I can replace this here, and if I do that, remove it and replace it with this. And now all I have to do is open that bracket. If I open the bracket, what do I get? I have my 1 there, then I have my 2 cosine of x, and then if I open this bracket, I get 4 cosine of x and cosine squared of half x, okay? So 4 cosine squared of half x multiplied by cosine x, and then I open the bracket for the negative 1 there, I get minus twice cosine of x, and then I have the one that was already outside, okay? We are done with this problem. 1 there will cancel with negative 1, as you can see there, and positive 2 cos x also cancels with negative 2 cos x there, and you can see we are only left with this term here, and so the left hand side is suddenly equal to 4 cosine squared of x x over 2 times cosine of x, and this is the same as the right hand side there, and so we've proved that we've proved the required identity, okay? So that's how you go through that problem. It wasn't very difficult. Let's see the next part of this question. Part B, part 1 of this question says to express 5 sine x minus 12 cosine of x in the form r sine of x minus alpha, like this, okay? So if we're going to do this, the first thing we need to do is to open that bracket, okay, to expand this, and this we expand using the compound angle formula. The compound angle formula for sine A plus B or sine A minus B gives us sine of A plus B or A minus B is sine A cos B plus minus sine B cosine of A. So that is to say that if we are given A plus B, then this side is also going to be plus, and if this is minus, then this side is also going to be minus. So in our case, we have A minus B. So we are going to use the lower case, which is to say that sine of into bracket x minus alpha is going to be sine x cos alpha minus sine alpha cosine x. Just the same way we've done this. So let's do that. And of course there is a coefficient r there which will then be distributed. So r sine of into bracket x minus alpha is going to be r sine alpha sine x cosine alpha minus r sine of alpha now cosine of x, like that. Okay, and once we've done that, the next thing is to equate what we've got here with the left hand side. So we are saying this must be equal to that because that's what we had said earlier. All right, this is coming from that equation, and so this is what we equate to that now, and then we compare the terms like that, and I think I've already put them in color code. So the first term here contains sine x. We look for the term containing sine x here, which is this one here. All right, I'm writing back that there. So the first term contains sine of x. Sine of x is here. The second term contains cosine of x. Cosine of x is here. So we will equate the coefficient of sine x here with the coefficient of sine x here, which is to say that r cosine of alpha must be equal to 5, and r sine of alpha, which is the coefficient of cosine x, must be 12. So this is minus and that is minus. Therefore, r sine of alpha must be 12, or you can say negative r sine alpha here must be the same as negative 12. So therefore r sine alpha is the same as 12. So let's put those down. So r sine alpha is 12 and r cosine of alpha is 5. All right, let's write those down. So r sine alpha is 12. I'll call that my equation 1 or equation A, and r cosine of alpha is going to be my equation B, like that. And now working with this, I can find my value of alpha and my value of r, okay? So given those two values, if I just divide equation A by equation 2, then I have r is going to cancel. So I'm dividing equation 1A by equation B, then I have r sine of alpha over r cosine of alpha must be equal to 12 over 5. Basically, this is cancelling with that, so we have tan of alpha is 12 over 5. So alpha is arctan 12 over 5, which we have found on the calculator. All right, the second thing we also need to do is we square both of those. So r squared sine squared of alpha is 12 squared, which is 144, and r squared cosine squared of alpha is the same as 25 because of 5 squared. If I add these two, this gives me, if I add them together, I get r squared sine squared of alpha plus r squared cosine squared of alpha must be 144 plus 25, which is 169. And I can write this as r squared into sine square of alpha plus cosine squared of alpha is 169. Now we know sine squared alpha plus cosine squared of alpha is actually 1. So this thing, the whole thing in the bracket is just 1. So we are saying then that r squared is 169, meaning that r is actually 13. So we know the value of r as 13. If you work out this on your calculator, you should find this is about 67.38 something degrees. So therefore we know the value of alpha and we know the value of r. We can therefore express this. So this must be 13 sine of x minus 67.4, like that. Okay? So this is not very difficult to do. This is always the process, and you can do it for cosine as well. So we could also express this in terms of r cosine of something like this. Okay, the value of r is likely to be the same. The value of alpha is probably going to be different. And so let's just put this neatly now. The solution that we've just found. So of course, when we divide equation A by B, all right, we get that tan of alpha over cosine of sine of alpha over cosine of alpha is going to be 12 over 5. Sine over cosine is tangent, so tan alpha is 12 over 5, and that means alpha is approximately 67.4 to 1 decimal place. The answer you give, of course, depends on what the examiner wants you to give it to. Could be significant figures or decimal places, doesn't really matter. Sometimes the examiner will want you to leave it as exact, so that would mean you write alpha is arctan 12 over 5, and that's also appropriate. Okay, the next part is to find the value of r, which we've also found. Square equation 1 and equation 2 and then add them together. So sum of squares, so r squared sine squared alpha is 144, so that squared must be this squared, and similarly r squared cos squared alpha must be 25. So if we add, the left hand side must be the sum of the right hand side. Okay, and then of course the stuff in the bracket is the first Pythagorean identity, which must be equal to 1. And so r squared there is simply equal to 169 and r is equal to 13. And because of that, we can now express our value there. We can now say that our expression can be reduced to the form 13 sine of into bracket x minus 67.4 degrees, like that. Okay, we have expressed this as required. I think the next part requires us to solve an equation involving this. So let's see what we get for part 2 of this problem. All right. So part 2 says hence. So when an examiner says hence, it means you must make use of your previous result to solve this problem. So you may choose to, if you choose to solve this using a different method that does not involve the result you found earlier, you will be penalized, you will not get the marks. So you always have to make use of the result from the previous part. And from the previous part, we have found that 5 sine x minus 12 cosine x can be expressed as 13 sine of x minus 67.4, like this. So we can express it this way. All right, so in place of this, we can use this. So if we are solving this expression equal to 6.5, so in place of this, we remove and put this, and we have 13 sine of x minus 67.4 must be 6.5. Divide both sides by 13, and we get that sine x minus 64 is a half. So this is 6.5 over 13, which is basically a half. All right. So therefore, find the inverse of both sides. So then we get x minus 67.4 is sine inverse, must be equal to sine inverse, or this, I think. So this has to be equal to arc sine of a half. The angle of sine is a half, and that is definitely 30 degrees and 150. And these are angles within 360 degrees. We are told to find our values between 0 and 360. And so the values we expect there is 30 and 150. And we have x minus 67.4 is either 30 or 150. So we need to take the 67.4 to the other side, and we get that x is either 97.4 or 217.4, there like that. So our results are x is 97.4 and x is 217.4. I believe I did that calculation correctly, that addition. Yes, and this is the answer to this part of the question. Okay. Thank you very much. I hope to see you in the next question.